Okay, example 4 is here to caution you that there are times when it's very difficult or maybe impossible to apply the multiplication rule. This is the reason why we're going to have 3 other ways of counting, sort of like the addition rule, the subtraction rule. There's going to be permutations, combinations. So multiplication does not always work. And here's a situation where it may not work. So there are 3 officers, a president, a treasurer, and a secretary that have to be chosen from 4 people, Anne, Bob, Sid, and Dan. And suppose that there are certain restrictions. Anne cannot be the president, and either Sid or Dan must be secretaries. How many ways can the officers be chosen? So the problem here is that if you're chosen as a president, you cannot be also treasurer and secretary. So basically there's a situation with no repeats allowed. And there are certain restrictions on, for example, Sid and Dan. They have to be secretaries, but they cannot be treasurers or presidents. So that screws up our calculation. So let's make a tree and look at the tree and figure out what's going to happen. And in this tree, I'm going to pick the president first. And after choosing the president, I'm going to choose the treasurer. And after I choose the treasurer, I'm going to choose the secretary. Okay. So let's say I'm trying to select the president. So who can be president? So there is 4 people, but at the same time, I know that Anne cannot be president. This is the reason why I have 3 little arrows. Bob can be president, Sid can be president, or Dan can be president. Okay, sounds good. Let's move on and let's figure out who the treasurer must be. So president is chosen. How about treasurer? Okay, let's say Bob is already president. Then who could be treasurer? Well, Anne can be treasurer, or Sid can be treasurer, or Dan can be treasurer. So far there are no issues. Now suppose that Sid was the president. Who can be treasurer? Again, Anne can be there, or Bob can be there, or Dan can be there. Okay, and finally, same thing again, A, B, and C. So A stands for Anne, B is for Bob, and C for Sid. Now, this is me doing the work without looking ahead to the next step, but I may have to erase some of these choices right now because they won't be logical. But let's take a look at who can be secretary next. So let's take a look at when Bob is president and Anne is treasurer. Who can be secretary? Well, it's either Sid or Dan, and there are no issues with that because they have to be secretaries. So that's great. Now, if Bob's already president and Sid is treasurer, who can be secretary? Is it possible for Anne and Dan to be secretaries? The answer is no. Remember, Sid or Dan must be secretaries. Nobody else is allowed to be secretary, so that means A choice is going to be gone. And this is the first problem with the tree. Okay, that branch right there is not super symmetrical. So let me redesign it. So there you go. All right. So now, what about if Bob is president and Dan is the treasurer? Can Anne be secretary again, or can Sid be secretary again? And the answer again is no. Anne cannot be the secretaries. She has to be something else. So Sid is the only person that's allowed and left over. So again, he's the only possible choice. Okay, in the same way, I'm going to go through all the other possible choices for the next scenario. So let's fill them up. Okay, and we run to the situation where Sid was president and Dan is the treasurer. But unfortunately, in that case, there won't be a choice for secretary. We cannot have Bob or Anne be secretary. So this choice is nonsensical. It cannot be that Sid is president and Dan is treasurer. So that choice is not allowed. So we have to kind of remove it from the tree. Okay, and let's keep going again. When Dan is president, Anne is the treasurer. Sid can be secretary. When Dan is president and Bob is treasurer, then Sid can be secretary again. However, if Dan is president and Sid is treasurer, then nobody can be secretary. Nobody's allowed, so that choice has to be eliminated. Okay, again, as you can see, this tree looks way different than the tree that we started off with earlier. So this is a problem. This is a non-symmetrical tree. The choices cannot be made in the same amount every time. So like, for example, choice 1 can be made in 3 different ways. Choice 2, sometimes it's 3 options, sometimes it's 2 options. It's not the same throughout the whole problem. And similarly with step number 3, sometimes you can have 2 choices, sometimes you have 1 choice only. Okay, so again, That's the reason why the multiplication rule does not apply in this problem. However, now that we have the tree made, how many possible branches can this tree have? So 1, 2, and so on and so forth. So counting all of them, we get 1, 2, 3, 4, 5, 6, 7, 8 different ways of choosing officer. So we're going to write down there are 8 ways of choosing officer. Okay, so that's basically the solution, the 8. Okay, and the justification is that tree that we just made. So now the question is there a way to rearrange the decision-making steps in the last example so that the tree can be used and can be prettier than this? So the answer is sometimes it is possible. So for instance, if I take this tree and rearrange who I choose first, so I chose president first, then treasurer, then secretary. If I rearrange that, then sometimes the tree becomes symmetrical. And the idea is to put the position with the most restrictions first. So in this case, in this problem, secretary is the most restricted one. It has 2 restrictions. So we're going to put it first. The next position that has less restrictions is the treasurer. We're going to write that down next, and then finally pick the president. So in this case, we're going to be going with secretary first, and then the president, the treasurer, and then president. Treasurer, and then president. So let me design the tree and show you what that looks like. Okay, so I had to redesign the tree and the decision making. I forgot that the president has to be restricted a little bit more than the treasurer, so that's why I rewrote president in the middle and secretary at the beginning. But there you go, the tree is basically now finished. And so with that tree, you can notice that the first branch has 2 choices, the second branch has 2 choices always, and the third branch has 2 choices always as well. So basically there are 2 different ways of picking the secretary, there are 2 different ways of picking the president, and there are 2 different ways of picking the treasurer. This is the reason why 2 times 2 times 2 would have been also 8 ways. So that tree is a little bit better, and again, the position with the most restriction is first, and so on and so forth. Okay, so pick the position with the most restriction first, and so on.